In this session, we will explore data allocation strategies. These are the techniques for distributing data across multiple sites in distributed systems. Consider these strategies as methods of storing and managing your data in a network of computers, rather than just on one. Data allocation is important for several reasons. It minimizes communication costs between different sites in a distributed system. Effective data allocation improves data availability across the network, ensuring that data is accessible even if one site goes down. It balances storage utilization across sites, preventing any single site from becoming overloaded. Finally, it reduces query response time for end users by placing data closer to where it is needed. When designing a data allocation strategy, several key considerations should be taken into account, including access patterns and query frequency, understanding how often and in what manner data is accessed. Also, network bandwidth limitations, data consistency requirements, and site reliability and potential failure scenarios. Let's look at the primary data allocation strategies. The first strategy is centralized allocation. With this strategy, all data is stored at a single central site. Other sites must access this central repository for any data needs. This approach is simple to implement, but it creates a single point of failure and a potential bottleneck. Another strategy is replicated allocation. Complete copies of the database are stored at multiple sites, allowing local access to all data from any site. This improves availability and read performance, but it increases storage requirements and update complexity. The final strategy is partitioned allocation. With this strategy, the database is divided into disjoint fragments, with each fragment assigned to a specific site. This reduces storage requirements, but may increase communication costs for complex queries. Now, let's compare centralized allocation with replicated allocation. In a centralized allocation, there is one central database, and all sites must request data from this central location. In replicated allocation, each site has a full copy of the database, enabling them to access the data locally without needing to communicate with the central site. Partitioned data allocation divides a database into smaller, more manageable parts. There are primarily two ways to partition data. First one is horizontal partitioning, and the second one is vertical partitioning. Horizontal partitioning splits a table by rows, with each partition containing a subset of the complete records, and in vertical partitioning, the table is split by columns, with each partition containing a subset of the attributes. Hybrid data allocation combines multiple allocation strategies to optimize data management. In this example, we have several sites each storing different types of data. The users, products, inventory, and analytics data are partitioned across different sites, meaning each site is responsible for managing its specific dataset. The configuration data is fully replicated across all sites, ensuring that every site has access to the latest configuration settings. The orders data is partially replicated across Site 2 and Site 4. Partially replicated means that only a subset of the orders data is stored at these sites, likely based on specific criteria such as geographical region or customer segment. Here is a legend. The blue color represents partition data, the orange color represents fully replicated data, and the purple color represents partially replicated data. Here is a comparison of the different data allocation strategies. A centralized strategy has low data availability and query performance, high storage efficiency, and simple update complexity. The fully replicated strategy has high data availability and query performance, low storage efficiency, and complex update complexity. The horizontally partitioned strategy has medium data availability and query performance, high storage efficiency, and moderate update complexity. Finally, hybrid approaches have high data availability and query performance, medium storage efficiency, and moderate update complexity. When designing a data allocation strategy, it is important to analyze access patterns before choosing an allocation strategy. Consider the network topology and bandwidth constraints. Use hybrid approaches for complex applications. Implement proper consistency protocols for replicated data, and design for fault tolerance and disaster recovery. For example, a global e-commerce platform uses hybrid allocation. Product catalogs are fully replicated across regions. User profiles are horizontally partitioned by geography, and transaction histories are partitioned with selective replication. Here is a pseudocode for data access decision. The function getDataLocation takes data type and user region as input. If the data type is catalog, return local replica. If the data type is user profile, return region shard for the user region. Otherwise, return master site. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.